Jupyter is an open source and an interactive web-based Python interface for data science and scientific computing. Some of its advantages are that it provides very rich and powerful Python language support. It allows you to create and share your Jupyter notebook and also contribute to other notebooks online. It has several interactive widgets, which make data manipulation and data visualization easier in real time. It seamlessly integrates with big data platforms such as Hadoop and Spark, and performs data analysis more productively and efficiently. Most likely, you wouldn't need to follow this step because the Anaconda installation would automatically take care of it. In case it doesn't, follow the steps here to install Jupyter Notebook on your system. Type the command conda install Jupyter on Anaconda prompt and press enter to execute it. Ensure that you are connected to the internet. It will fetch and download all the required libraries from the internet. Once the installation is complete, you can launch the Jupyter Notebook, which will open in a separate web browser. You can similarly install other Python libraries. Visit the relevant sites to find the appropriate command lines. We are now done with setting up the Python environment. We'll move on to revising and learning some basics of Python. Let's create a basic Python Jupyter notebook, as you can see here. It's running as a web application at port 8888 on localhost. Let's first import the sys module and verify the version of the downloaded Anaconda platform. You can also import the platform library to view the Python version. Let's try to create and print a test string. As you can see, the Python interpreter successfully generates the string output. You can also try out some basic mathematical operations, such as addition and multiplication, to test if the installation is working well. A variable can be assigned or bound to any value. When you assign a value to a variable, you are creating references and not duplicates of the value. I'll explain this in greater detail later. For now, you just need to understand how values are assigned to variables. Remember that the variable should appear on the left, followed by an equals sign, and then the value itself. You can see that no matter what the data type of the assigned value is, be it integer, float, or string, you don't need to separately specify the data type of the variable. The variable directly takes on the data type of the assigned value. Let's look at an example. Here, we assign a string value and integer value to the two variables. To print these variables, type print, followed by the variable name. To view the data type of the variables, use the print type method and specify the variable names within the parentheses. Now let's see if you can access a variable without actually defining it. You can see this throws an error. Let's fix it by assigning a value to the variable. This proves that a variable can only be accessed if it is defined or has an assignment. You can also make multiple assignments simultaneously. To view the variables, type their names. Remember that when you assign a value to a variable, you are creating references and not duplicates of the value. Let's try and understand what that means. Here in this example, we're assigning x the value 7. Since 7 is an integer data value, x becomes an integer data type as well. Now, on the back end, what happens is that an integer value 7 is created and stored in memory. Then a name or variable x is created. It's assigned a reference address of the memory location where the value 7 is stored. So x refers to 7 and therefore holds the value 7. If we increment x by 1, then what really happens is that the reference of the name x is looked up. The value at the reference is then retrieved. The 7 plus 1 calculation occurs, producing a new data element 8, which is stored in a fresh memory location with a new reference. The variable x now refers to this new address. The old value is now no longer needed and is therefore discarded. You have looked at how variables can be assigned values. It's time now to look at some basic data types in Python. The two main numeric Python types are integers and floats. Floats are decimal numbers. That's how they're referred to in all programming languages. The size of the integer which can be stored as an int is dependent on your platform, whether it's 32 or 64-bit. But large integers are automatically converted to long type by Python. Here, you can see that we divide two numbers. It's important to remember that if the numerator and denominator are integers, then the result will also be an integer, even if the accurate answer is a float. However, if either the numerator or denominator is a float, then the result will also be a float. So you can see that mathematical operations in Python largely depend on the data types of the numbers involved. Python has extremely powerful and flexible built-in string processing capabilities. There are multiple ways to create string objects. You can enclose them with single quotes, double quotes, or three double quotes. All three ways generate similar outputs. Python also supports the none and Boolean data types. None is the Python null value type. If a function does not explicitly return a value, it implicitly returns none. The two Boolean values in Python are written as true and false. Comparisons and other conditional expressions evaluate to either true or false. In this example, a variable is assigned a value none. To check if the assignment occurred correctly, you can use the keyword is as shown here. You can see that it returns a Boolean value, which is true in this case. Now assign an integer value to the same variable and check it again. As expected, it returns false this time. You can also typecast a number from one data type to another. For example, let's define a float as shown, and then print its data value. To cast this float value to an integer, use the int function as shown here. You can see that it generates an integer output. Similarly, to cast a float value to string, use the str function, and it will return a string output. A tuple is a one-dimensional, fixed-length, immutable sequence of Python objects. Immutable implies that its content cannot be modified. The easiest way to create a tuple is to provide a comma-separated sequence of values. In this example, a tuple is assigned a bunch of mixed comma-separated data type values enclosed within parentheses. Let's view it by referencing the tuple object. To access the tuple element at index 1, use the syntax shown here. The index usually starts from 0. If you try to modify the value at a specified index, it throws an error since a tuple is immutable. As you saw earlier, you can use the index of an element to view and access it. To access elements with the help of positive indices, count from the left starting with 0. You can also use negative indices by counting from the right starting with -1. Negative indices are useful as they help you to easily refer to elements at the end of a long tuple. You have seen how to access individual elements in a tuple. You can also access a range or slice of elements within a tuple. Slicing allows you to create a subset of the tuple. To slice a tuple, mention the indices of the first element and that of the element immediately after the last element. This is because while the first index is inclusive, the second one is not. For example, here you can see that referencing indices 1 to 4 creates a tuple subset with elements from index 1 to 3. You can also use negative indices to slice tuples as shown here. In contrast to tuples, the length of lists is variable and their contents can be modified. They can be defined using square brackets or using the list type function. Here, a list is defined using comma-separated values of mixed data types. You can view the content of the list by just referring to the list object. You can use the append method to add a value to the list. Note that this value gets added to the end of the list. You can also remove any particular item by just referring to the element value. You can see that Mark is no longer part of the list. 101 is now the first element. Use the pop method to simultaneously view and remove the value at a particular index. Similarly, use the insert method to insert a value at a particular index. Note that Smith is now included at index 1, while test, which appeared after 23.6, is not there anymore. Just like tuples, you can access elements in a list through indices. As you have learned earlier, positive indices are counted from the left starting with 0. By providing the positive index, you can access the specified list element. Recall that negative indices are counted from the right, starting with -1. Since -2 refers to the second element from the right in the list, the value 11 is generated as the output. As you sliced tuples, you can also slice lists. Recall that to slice a tuple, the indices of the first element and the element immediately after the last element must be specified. The same is applicable to lists. You can also use negative indices to slice lists, as shown here. Dictionary is likely the most important built-in Python data structure. Dictionaries are mappings of a set of keys to a set of values. Keys are variables, and they are listed together with the values assigned to them. This forms key-value pairs. The keys can be of any immutable type, and the values can be of any type. A dictionary is a flexibly sized collection of key-value pairs, where keys and values are Python objects. You can define, modify, view, look up, and delete the key-value pairs in the dictionary. The difference between view and lookup is that view allows you to view the entire object, while lookup lets you access a particular element within the object. You can create a dictionary using colons to separate keys and values enclosed within curly brackets. In this example, the dictionary contains 3 key-value pairs separated by colons and enclosed within curly brackets. You can view the content of the dictionary, or dict, by referring to the dict object. Use the keys method to view all the keys. Similarly, use the values method to view all the values present in the dictionary. You can also access and modify individual elements in a dict. To access a value, pass the key name to the dict object. In this example, passing the name Kelly retrieves the associated value, which is the email ID. Similarly, passing ID retrieves the values associated with it. You can access only one value through the key. Use the update method to update the value for a corresponding key. Here, you can see how the values for ID are updated. You can also delete a key with the help of the delete function. You can see that the ID key and the values associated with it have been deleted from the dict. A set is an unordered collection of unique elements. You can think of them as dicts, but without values. You can create a set using either the set function or by listing all the elements within curly brackets. If you check the object's type, you can see that it shows up as a set. To view the set, type its name. Note that BMW and GM, which are mentioned twice, appear only once since a set only contains unique elements. Let's understand set operations through an example. Create 2 separate sets of auto survey. Now try to generate a combined survey report using the OR operation, which is a union operation. Note that the combined survey report does not contain any duplicate values. Use the AND operation, which is an intersection operation, to view the common elements between both sets.